using a parameter h. So again, we were introduced to different parameters and functions here. We have the definition of a function. It's a relation that assigns exactly one output value for each input value. We have our examples here where we have our relation and we have our equations. And from those equations, we can go ahead and write them into functions. We have our non-examples here. We have another relation where we can go ahead and see that it's not a function. And we have also a graph where we can see that it's not a function as well if we were to do that, that vertical line test, of course. All right, so a new definition that we introduced last time was a parameter. And a parameter is a number that transforms a function into another function. So we can go ahead and say that it's transforming it into a new function. So we can go ahead and say that it's f of x, and then we can go ahead and say that because it included a new parameter, we can go ahead and say that it's now g of x as well. All right, so function notation, just a little reminder, we're going to go ahead and not write y equals. We're now going to write f of x instead, okay? So we're using that function notation in this section. Okay, so here's our function that we're going to go ahead and focus first. We have f of x equals x squared. And we're going to go ahead and create our table so that we are able to find the values. Okay, so let's go ahead and create our table, our values. X squared, well, if we were to input our value of x into our function, just a reminder, this is how we write it, f of x. Our first value is -2. Therefore, we write f of x or f of -2 equals -2 to the power of 2. And therefore, we get that result of -2 times -2, which equals +4, right? So here the value is 4. All right, can you guys give me the next values for -1, 0, 1, and 2? Anyone? Okay, I'll help you guys out for the next one. Thank you. So for the next one would be +1, correct? How do you do that? We're going to go ahead and input into our f of x, where we have -1. And wherever we have an x in our function, we're going to go ahead and input that value here. So here is our function. Here is our x. We're now going to write -1 to the power of 2, which means that we have now -1 times -1, which gives us that +1. We can go ahead and do the same for 0. F of 0 equals, inside parentheses, 0 to the power of 2. Therefore, 0 times 0 is going to give us 0. All right, who can do the next one? One, thank you, that is correct. And the last one? 4, that is correct. All right, so we were able to create our table using that domain of -2, -1, 0, 1, and 2 with our function f of x equals x squared. Notice that for every x that's present in my function, I input the value. All right, so we were able to start from there. Okay, so let's go ahead and go on to our next slide here. Our next slide already gives us our value. We have 4, 1, 0, 1, and 4. That's our range that we have here now. We are able now to introduce that new parameter. So now that we have our new domain and our range, we can go ahead and now introduce the new parameter. So this new parameter that we're going to go ahead and see is what we call parameter h. What does it do to our function? That's what we're going to go ahead and see in this example that we have here. But before we introduce it, or before we have our example, notice its position. So its position here is basically inside of our parentheses, right? So we have our function of, and we're going to go ahead and say x minus h. So parentheses, x minus h. So whatever number is here, that's what we're going to go ahead and do as a function first before we can go ahead and compute what the value of f of that function is, right? Now, here's my example that I'm going to demonstrate. I have f and then inside parentheses, x minus 4. All right, so let's go ahead and get to it. And I think I changed it. Yeah, I changed it to f of x minus 2. Okay, so let's go ahead and do this one. Now, how exactly do we write it? Notice here that our f of x, or now our new f of x minus 2, is written this way. Okay, so let me go ahead and write my f x minus h, where my h in this instance equals positive 2. Okay, notice that in our function notation here, our h already has that negative sign. So if we were to say that it's negative 2, we were to say that our function here has to be plus 2 because we have to take that negative out, basically. Notice that the standard way that we write it is f inside parentheses x minus h. So that negative is already included. So it's f inside parentheses x minus 2, where our h is positive 2. Okay, so now how do we compute all this? So if we were to use our regular function here, we have our function equal to x squared. We're not going to have x squared anymore. We're going to have x. Now what happened to our x? We subtracted 2 from it. So wherever there is an x present in your function, you're going to substitute it. So we're going to go ahead and substitute it by x minus 2, wherever there's an x. So in this particular example, there's only one x here. So instead of just writing x by itself, we're now writing x minus 2. Okay, so we're going to go ahead and compute now what that value is for each of our domains. So for -2, -1, 0, 1, and 2. This one's a little bit different from our parameter k because this one doesn't happen afterwards. It happens during our solution here. So this is how we do it. We're going to go ahead and do the first one. I'm going to go ahead and write my function f, and I have x minus 2, and it equals x minus 2 squared. All right, so my first x that I have here is x equals -2, right? That's my first x that I have here. I'm going to substitute every value here and the same over here as well. So let me see. I'm trying to write as legibly as I can. F of x, -2, -2, and f of -2 minus 2. Not f, sorry. I got a little carried away. So -2 minus 2 squared. All right, so all I did is substitute that x value of -2. Now this is going to be my f of x. -2 minus 2 gives me -2 minus 2, -4. And it's going to be on my right side over here. -2 minus 2 gives me -4. -4 squared. Well, let's go ahead and do that now. -4 times -4 gives me positive 16. So there's a little extra steps involved here. this doesn't happen afterwards. It happens during our function here. And there's going to be a lot of work done, which is okay. But we can go ahead and take it step by step and figure out which each of the values are. So let me go ahead and do the next one so to help you out. I'm going to go ahead and do the next one in red so you can see the next work. All right, so next one, I'm going to go ahead and write my f of x. And this time my x equals, let's see, x equals -1. Let's see, so it's -1 minus 2 equals -1 minus 2 squared. At this point, if you go ahead and rewrite everything on the left side, you have -1 plus -2. We have -3. And over here as well, -3 squared. So -3 squared in this example, -3 times -3 gives me +9. All right, go ahead and do the same for the next values. Let's see what you guys get. Zero is not 0. I do have the result. The result is 4. That's correct. And for 1, does anybody have the 1? For 1? 1 is 1. That's correct. And for 2? 0. That's correct. All right. So the same process will happen, and you continue to substitute those values in for that x, right? And then you can go ahead and solve for it. So let's go ahead and go on to our next example. Let me go ahead and save an image so I can come back to it. If at any time you guys need me to come back to the screen, I can go ahead and do so. So you guys can finish up your notes. Let me go ahead and clear this out. Let me move on to the next example. So here is finally our first example. We were able to create that first table of our f of x. And we were now able to create that, that table or a new function that we have f x minus 2 or f of x minus 2. And we're going to go ahead and first graph this example here. So we can go ahead and first graph our first function. Then when our first transformation happened, which we had our h equal to 2. So this is where h equals 2. And then we're going to go ahead and have a different type of example as well. So let's go ahead and first graph our first function. I'll graph it in blue so you guys can see it. So our first function at -2, it's +4. At -1, it's +1. At 0, it's 0. At 1, it's +1. At 2, it's +4. So we created that beautiful parabola that we know. At 3, it's 9. So let me go ahead and graph it at 3. So it goes all the way down here. It curves, goes through 0, and it curves right back up, right? Imagine that's beautiful. That's done very perfectly. Okay, so now let's go ahead and graph our next function. Our next function is f, and then inside parentheses, x minus 2. So f of x minus 2. So let me go ahead and graph it in red so you guys can see it. So this time we have -2 and 16. So this one will go outside of our graph, which is okay. -2 and 16, let's imagine that it's all the way up here. So it's 10, 11, 12, 13, 14, 15, 16. So all the way up here. Next, I have at 1, 9. At 0, I have 4. At 1, I have 1. And at 2, I have 0. So I'm going to go ahead and continue. If I were to continue this graph and graph it so that I have it exactly here, I can go ahead and continue it. At 3, it would be back at 1. At 4, it would be back at 4. And so on and so forth. And at 5, it would be back at 9. All right, so we were already able to see that our blue graph, our first function is here. This is our f of x. And our red graph, this is our f of x minus 2. Something happened to those positions, right? Notice that its lowest point, it's still touching our x-axis. And notice that some points are still almost towards or right next to each other. Notice these points. So let's go ahead and continue on with our next example. So our next example now, instead of writing f of x minus 2, we're going to go ahead and write f of x plus 2. In this particular example, we have our h. Come on. Our h equal to negative 2. Why negative 2? Well, if you remember, really? There you go. Negative 2. If you remember our function, our parameter function, x minus h, notice that our h is negative. So whatever comes out of it is going to be its opposite value. So if it's positive, then its h is negative. If it's negative, then its h is positive. Okay? All right, so let's go ahead and now let's go ahead and figure out those values now. For negative 2, negative 1, 0, 1, and 2. I'm going to write my, I need some blank space. So I'm going to go ahead and use my blank space down here. So I can use that for working area just for right now. And then I'm going to go ahead and continue with the work. So I'm going to go ahead and continue. Let's see. So how do we do this? The same process happens. F. We have our new domain. Our x this time is going to be negative 2. So we write negative 2 plus 2 equals, our function remains the same, x squared. So instead of writing x, we're now going to write that beautiful x minus 2, or x plus 2, sorry. So negative 2 plus 2 squared. So our function is now, let me go ahead and write it up here so you guys can see it. F of x plus 2 equals x plus 2 squared. So that's our new function that we have for this particular example. All right, so let me go ahead and now continue to solve. So we have f, let's see, negative 2 plus 2 gives us 0. So we have negative 2 plus 2, again, 0. And 0 squared here in this case would be 0. Okay, let's go ahead and do the same for negative 1. So x now equals negative 1. So we have f inside parentheses, negative 1 plus 2 equals negative 1 plus 2 squared, because that's our function. Wherever we have that x, we go ahead and substitute our new f of x, or f of x plus 2. And now we have, let's see, negative 1 plus 2 gives me positive 1 squared will now give you 1. All right, so I'm going to go ahead and let you guys do 0, 1, and 2. Let's see what you guys get. Awesome. All right, so I have somebody giving me the value for, let's see, our 0. So f of x plus 2. When x equals 0, that is true, that is 4. And the next value, so when x equals 1, and we have f of x plus 2, and that would be 9. And the last one would be 16, of course. So it kind of like inverses. It flipped the other way through. Okay, so let me go ahead and delete my work here. So I can go ahead and graph everything nice and beautifully. All right, we're getting the hang of it. Okay, so let me go ahead and graph this in purple, of course. That's the color that I have here. The first value that we have is at -2, it's 0. -1, it's 1. At 0, it's 4. At 1, it's 9. And the last one at 2, it's 16. So it's all the way up here. All right, and if I continue, it would be again at 3. I think it would be at 1. This would be 2, and again 4. 4, -4. And the last one would be at 9, of course. Since it's a parabola, and a parabola mirror images itself. Okay. So we can go ahead and now graph our last one. Parabola is symmetrical to itself, so we can go ahead and just write the points right the same distance from each other. Okay, so now in this case, now by looking at the 3 graphs on our beautiful graph here, what do you guys notice? Remember that our original one was our f of x, our blue. Now we have, let's see, when we had our h equal to, what happened to our red graph? And the same with, again, our original f of x in blue. What happened to our purple graph when we had h equals -2? So I have saying, yeah, people are saying that it went to the right. So when exactly did it go to the right? So if you notice that when h equal 2, or in this case, my f of x minus 2, when I had my h equal 2, it went 2 steps to my right. Very similarly, when h equals -2, my whole function just shift 2 steps to the left. So we have to notice here exactly what the values are and see what happens depending on what function I have here. So, all right. So I feel a little bit more confident of how you guys are doing here. Let's see. Let me go ahead and save an image so I can go ahead and come back to this. Let me go ahead and clear all this. And I have a next one for you. This one's going to be your exit ticket. So you guys can go ahead and complete it on the Nearpod lesson. I have f of x, and this time I have the absolute value. Remember, absolute, anything that goes into your absolute value comes out to a positive value of 2x. And we use a domain of -2, -1, 0, 1, and 2. Okay, so this, you're going to go ahead and do asynchronously. You don't have to stay in the meeting, but this is your exit ticket. So you're going to go ahead and show me exactly what it is. And this time, our first function, f of x, our second function, f of x minus 3, and our last function, f of x plus 4. Okay, any questions on this so far?